In this video, we will talk about three basic logic operations: conjunction, disjunction, and negation. Conjunction, which we generally call AND, is denoted by this notation, which looks like A without a bar in the middle. Disjunction, which we generally call OR, is denoted by this notation, which looks like a V. And negation, which we generally call NOT, can be denoted by one of these three notations. In this video, we will be using this notation. But these two, the other two, are very commonly used also. Now let's look at a few examples. We are given P and Q as these two statements. P is a statement, I take a statistics course, and Q is the statement, I take a computer science course. We want to write these combinations of P and Q. The first one is P and Q. Let's quickly write that here. P and Q. So this will look like I take a statistics course, and you can say I take a computer science course, or simply a computer science course. So that's the conjunction, and connecting P and Q by logic AND. Next, let's write down P or Q. So this will be I take statistics course or a computer science course. Now let's look at these two statements, and or. When you say and, you are taking both computer science course and statistics course. You must satisfy both of these statements, taking a statistics course and taking a computer science course when you say and. But when you say or, it could be at least one of these two. You could be taking just a statistics course, you could be taking just a computer science course, or you could be taking both of them. So when you say or, it should be at least, it means at least one of the two. As long as at least one of the two statements are satisfied, then we have or. Next, we have not P. So not P is negation of P. Then that will look like I do not take a statistics course. The next one is not Q. So not Q is negation of Q. Q is I take a computer science course. So not Q will be I do not take a computer science course. Now let's look at the next example. In this case, P is the statement, my cousin lives in New York, and Q is the statement, my cousin is married. We want to write down these combinations of P and Q. The first one, P and Q. So we basically just need to combine these two statements by and. Then I can say my cousin lives in New York and she is married. Similarly for or, P or Q, I can say my cousin lives in New York or she is married. Again, comparing this and statement and or statement, when you combine by and, both of these must be true. Your cousin must be living in New York and she must be married for the statement to be true. But when you combine by or, just one of these two may be true. The possibilities here are your cousin may be living in New York, but she may not be married, and the statement is still fine. The other possibility is your cousin does not live in New York, lives elsewhere, but she is married. And the third possibility is both of these are happening. Your cousin lives in New York and she is married. So all of these cases are included in or. Next, we want not P. Not P is simply negation of P. My cousin does not live in New York. And the last one is not Q. So negation of statement Q. My cousin is not married. So we are done with this example. Let's look at the next one. Here P is the statement that X is greater than 2, and Q is the statement that X is less than or equal to 6. Now let's write down the combination of P and Q. First one is P and Q. So this means X is greater than 2 and X is less than or equal to 6. Now this we can combine as 2 is less than X is less than or equal to 6. The next one, P or Q, we have X greater than 2 or X less than or equal to 6. So X can be any number that is greater than 2 or any number that is less than or equal to 6. So if we combine these two, we get all the values from negative infinity to infinity. Because if we look at the first statement, I'm going to draw a number line over here for X greater than 2. And I'm going to put 6 here because 6 is our another value of interest. X greater than 2 will give us these numbers. And X less than or equal to 6, I have 2 here, 6 here, will give us these numbers. So when I say P and Q, X greater than 2 and X less than or equal to 2, only the numbers that satisfy both of these conditions. So the first one is just this part and the second one is that part. So the numbers that satisfy both of these conditions are the numbers that are between 2 and 6, including 6. So we have that. Now when we say P or Q, we have X greater than 2 or X less than or equal to 6. So we include all the numbers that are in this set and all the numbers that are in this set. So we can include all those numbers from both the sets. We just put them together and that will include all the real numbers. So from negative infinity to infinity. Next, we have not P. So not P is the negation of P. That means we must have X less than or equal to 2 because P is greater, X is greater than 2. The last one, not Q, is negation of Q. Q is X is less than or equal to 6. then not Q should be these numbers, X greater than 6. Now let's look at the next example. Here we have a combination of some statements given, and we want to break this into a number of statements and write in a symbolic form. It says, let G be Mary has a college degree, let L be Mary lives in London, and W is the statement Mary is wise. It says Mary has a college degree, she lives in London, and she is wise. So basically we are connecting all these three statements with and, then it will look like G and L and W. And the order of operation doesn't really matter. If we want, we can put a parenthesis like this here, or you can put parenthesis between the first two also. So this is the symbolic form of given statement. Next example here, Mary does not have a college degree, but she lives in London and she is wise. The first part is negated, so we have not G, and she lives in London and she is wise. Then we can say and she lives in London and she is wise. Again, since these three are connected by and, I can group them in any way I like. So I can put the first two in one group and then connect with the third one with and, or I can also write this as not G and L and W. So either one is perfectly fine. The next example here, Mary has a college degree, but she does not live in London or she is not wise. So in this case, we have G first, and she does not live in London or she is not wise. Then we have not L or not W. So this is the symbolic form for this given statement. Okay, next example. We are given -5 is less than or equal to x is less than 10. P is the statement that x is greater than or equal to -5. And Q is the statement x is less than 10. We basically want to write this in terms of P and Q. First, we can try to break this into two statements. We can say x is greater than or equal to -5 and x is less than 10. Now, if we look at what we are given about P and Q, this is simply P and this is simply Q. So this statement becomes P and Q. So this is the symbolic form of the given statement. This one is very similar to the example we just looked at, except P is little different. Here we are looking at, again, let's break this into two statements. -5 is less than or equal to x and x is less than 10. Now this statement, if we look at it in terms of P or Q, the first one is simply not P because P says x is less than -5. And here we have x is greater than or equal to -5. So the first one is simply not P, and this is Q. So we have not P and Q. So this is the symbolic representation of the given statement. Now we have x less than or equal to 2 or x greater than 3. If we look at P and Q, the first part here is simply not P. P is the statement x is greater than 2. Here we have X is less than or equal to 2. So this is not P. Then we have or X is greater than 3, which is not Q. So using the symbol notation for or, we can write this as not P or not Q.